Alright, so this is the standard form of a parabola. Y is equal to ax squared plus bx plus c. So yeah, that's standard form. We're going to look at what's called vertex form. Now the benefits of standard form are that you can identify the y-intercept very easily. But not much else. So it has its uses, but its uses are minimal. Alright. Whereas vertex form, you may guess, allows you to very easily identify the vertex of a parabola, which is a bit more useful. Okay. So in standard form, the c term is the y-intercept. In vertex form, h comma k is equal to the vertex. You'll notice there's a negative on the h term, which means if this said x minus 3, the actual vertex would actually be located where the x coordinate is 3. So here's an example. If we wrote y is equal to 4 times x plus 3 squared minus 6, the vertex of this parabola is actually h, which in this case is actually negative 3, and k, which in this case is negative 6. So if you want to try and memorize it a little bit, it's the opposite of this term and the same sign, the opposite sign of this term and the same sign as this term. Alright, so let's take a look at how to write a parabola in vertex form. So let's just make one up. Y is equal to negative 2x squared minus 8x plus 16. Now I did try to make it so that they were multiples of 2, so it would simplify pretty well, but it might not. But we'll find out shortly. Firstly, the easiest thing to do is to remove this negative 2 here. In order to do that, we have to divide everything by negative 2. And that will give us y is equal to, well, y over negative 2 is equal to x squared plus 4x minus 8. Alright, now we're going to complete the square. So we're going to take a look at these two terms. Here's the square. We have x squared in the top left corner. We're going to disperse the 4x into both of the upper right and lower left corners. So 4x becomes 2x in each of those, which makes the square an x plus 2 by x plus 2 square, which means the bottom right corner, the completion value is 4. Alright, so here's what we're going to do. We're going to add 4 and subtract 4 on the same side. Now, in the previous examples, we worked with completing the square. Whatever we add to one side, we add to the other, but we don't really want to put anything with y, so instead of adding it over here, we're just going to add and subtract it here. So that gives us y over negative 2 is equal to x squared plus 4x. We're going to add a 4 here. At the same time, we're going to take it away right next to it. Alright. Now those three terms will become x plus 2 squared. So that gives us y over negative 2 is equal to x plus 2 squared. That leaves us with a negative 4 and a negative 8, which become negative 12. So we're almost done. We just need to move this negative 2 back up here. So to undivide by negative 2, we multiply by negative 2, and that makes this into y is equal to negative 2 x plus 2 squared plus 24. Now you'd be tempted to distribute this negative 2, but you cannot do that because exponents come before multiplication. So this is vertex form of this parabola. So looking back here, we can tell that the y-intercept of this parabola was 16. Now looking at vertex form, we can tell that its vertex is at negative 2, 24. Alright. I can also tell you that at negative 1, the y value is 22, because that's what the a value does. This first term, a. When you move the parabola over exactly 1 unit, it will move the parabola that distance vertically. So let's take a look at that. So this is a parabola, and just looking at it, we can tell what its vertex is, and its vertex is currently at negative 5, negative 3. So in vertex form, that would look like this. Y is equal to a x plus 5 squared minus 3. Now the value of a you can identify by looking at the vertical change when there's been a shift of 1 from the vertex. So if we move over 1 from the vertex, we see that the parabola actually shifted down 2. That makes a negative 2. So this is y is equal to negative 2 x plus 5 squared minus 3. It's kind of like a is the slope of a parabola, but it's not, because it's not consistent. If we actually were to go down go over 1 more unit, it wouldn't go down 2 again. It actually goes down much further. All right, but knowing this 1 unit idea will help you identify a very easily if you were looking at a graph. Another way to identify a, which we're probably not going to do, and it's probably not going to come up in the trig regents, but I just figured I'd show it to you because it's interesting. So imagine we didn't know what this is. We assume it was a. We'll just call it a. If we take any other point on the parabola besides the vertex, in this case negative 4, negative 4, negative 5, we can substitute it into x, y, and solve for a. So we'll actually be able to determine the value of a that way. So in this case, this would become negative 5 is equal to a times negative 4 plus 5 squared minus 3. So that's negative 5 equals a times negative 4 plus 5, which is 1. 1 squared is 1, so that's 1a minus 3. If we add 3 to both sides, we get negative 2 is equal to 1a, which means a is equal to negative 2, just like we said. Alright. So let's see how vertex form compares to transformations of functions, which we've been looking at lately. So y is equal to x squared is the parent function of the parabola. So let's take a look at that. That's here. Alright, in vertex form, we can shift the vertex using translations. So if we subtract 2 from y and add 3 to x, the parabola, and this would, we set it equal to y, we get this, which is vertex form, which has a vertex at negative 3, positive 2. Alright, because when we subtract a value from y, the vertex moves up. When we add a value to x, the vertex moves left. So you can see how vertex form will shift the parabola. Now, when we multiply y by a value, let's say 2, it divides the entire equation by 2. Alright, and if we remember what happens when we multiply y by 2, it actually has a vertical compression in the y values of every point on the parabola. So the vertex, every point on this parabola will have in its distance. So the vertex which was at 1 will shift, was at 2 will shift to 1. This point here that was at 3 will shift to 1.5, and so on. So that's how vertex form is directly connected to transformations. Alright? Alright, so one last example. I'm just going to make it up, so it's going to look horrendous. Alright, so this is y is equal to 3x squared minus 17x plus 18. Alright, so the first thing we're going to do is divide everything by this first term, so we have an x squared only term. So divide that by 3, and all of these by 3. Alright, so we get y is equal to, y over 3 is equal to x squared minus 17 over 3x plus 6. So I didn't even try to make this a fraction, just happened to become one. Alright, so we're going to complete that square, alright, which is not going to be very pretty. So this is x squared. The 17 over 3x is going to be split up here, so it's just going to become 17 over 6x and 17 over 6x. So that makes each side of this square x plus 17 over 6, which is going to be the x coordinate of our parabola. So this is going to become, so the value that completes the square is going to be 17 squared over 6 squared. What is 17 squared? 17 squared is 289. Alright. So we're going to add and subtract that here. So that's going to give us y over 3 is equal to x squared minus 17 over 3x plus 289 minus 289 plus 6. And these three terms, oh wait, 289 over 36, excuse me. So those three terms will become x plus, oh wait, I'm sorry, those are supposed to be negative. These are all supposed to be negative. So this is supposed to be negative, 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 negative. All those are negative. So that make that x minus 17 over 6 squared. What is 289 plus 36? 253, so that's negative 253 over 36. Now we have to multiply everything by 3 to get our final vertex form. So y is equal to 3 times x minus 17 over 6 squared minus 253 over 12. So this strange parabola I made has a vertex at 17 over 6, comma, negative 253 over 12. Alright, all that without using a calculator.